Okay, just to have briefly understand what we are doing. I believe all of you know me, not so?
Yes, madam.
Yes, yes. So I don't have to introduce myself. So like I said, this is curriculum development in computer studies. It's nothing new, but just we are realigning just the concepts towards IT. So let me go straight to what curriculum development is. And this one, I think you know it this better than me. I'm not an educationist, you are. So just that process of you being able to select what content you're going to use, organizing it, and then executing it, the actual process of executing and then evaluating to see if you're meeting the basic standards. So of course the objective of curriculum development is you're trying to bring about a transformation in knowledge, in the knowledge of an individual or individuals. The objective of, so when we're looking at it, we're trying to improve, to introduce, improve the knowledge of someone, or certain individuals. So that process of appropriate selection of that content to be delivered. Now, in this particular circumstance, we are looking at ICT or computer studies. It's computer studies. So computer studies, as we all know, are very practical. That's one. Two, it's an evolving industry. There are new things, new technologies constantly being introduced. Right now, the big thing is AI, then big data, and so on and so forth. So the student you want to bring out is someone who can quickly adopt to these changes. Right now, there are even other further developments. I was recently, not recently, but this past year and this year, involved with a committee in Uganda Matters University that is looking at what is it? The digital economy. Yeah, now we have industries that are embracing the digital world, and some transactions are coming through because of the digital world. Take an example. If I want to, the banking sector, the traditional banking sector is that you have a physical building where somebody goes and carries out their transactions, their financial transactions. But now, because the mobile network can connect with the internet and so on and so forth, you can see new technologies coming up. Same thing with agriculture, education, and so on and so forth. So now the idea is that every professional, whether you are leaning towards ICT or not, you should be literate in that area. Yeah. So let's move directly to ICT itself. Yeah. We are in the 21st century, and this is some of the things I've just been speaking about. We are now in the world of ICT, but specifically for you, you'll be training those professionals in the ICT world. So we need to be aware of what is going on. Two, we need to be aware of the obstacles that currently exist within our world. The first is the digital divide. Yeah. We need to develop this curriculum. We need to teach our students, but in an environment where we have limited or no access to ICT, or anything digital for that matter. So it is within those challenges that you will be introducing this subject to your students. So what are the elements of curriculum development in computer studies? Well, they are the same as before, just as like I said, we are now focusing on ICT or computer studies. So the first is aims and objectives. What should the students achieve? So being that ICT or computer studies are very practical, you may consider things like programming. What do you expect to do in programming? Yeah, you may consider the concepts. You may consider the skills. The skills are extremely important. You may consider somebody's design capabilities. All those. Then you think again of any other computer studies. Maybe it is networking. What are we thinking about? Troubleshooting, design, security, so on and so forth. So those would be the aims and objectives that you'd consider. So for us, for computer studies, the industry as well also dictates. The industry dictates. You're sending out this professional into the industry. What does the industry expect of a computer studies professional? What do they expect? And those are some of the things that become your objectives. Then your content, the topics to be chosen. What should be the topics? Methods, how you expect to teach, and the practical, when do you expect to have a lecture, when do you expect, things like that. Then assessment and evaluation, how do you expect to measure that that the student has attained those objectives? The stages of curriculum development, again, they also don't differ from what is in the generic. The first is needs assessment. So what is the gap that needs to be filled? In terms of the industry, then in terms of knowledge. Knowledge is what level are the students at right now? The student in Uganda may not be the same as the student in Europe. The student in rural Uganda may not be the same as the student in urban Uganda. Okay? So what is the knowledge level? Then there is designing and planning, setting up the learning outcomes. This is where you pick your objectives, your content, and so on. Then the actual development, creating the material, then implementation, this is the teaching, then evaluation. Sorry, my network, can you hear me? Sorry, can you hear me?
Yes, madam.
Okay, sorry, my computer is freezing up a bit. Let's give it a minute. Sorry. So this is the same curriculum development as discussed before. So for computer studies, what do we consider? We consider we don't just want to teach students how to use the computer, but how does the computer work? We want to move beyond just using the computer, Word, Excel, and so on and so forth, but the computational thinking. Then the relevance, alignment with the trends, the current trends that are going on in the industry, the current technologies that are coming out, accessibility and inclusivity, implementation and practical application, the hands-on. So we have different types of curriculum development. I think you know this quite well. These are not new to you. So I'll quickly move to, even the models are also not new to you. You have the Tyler's rational and Tapper's model, competence-based. So with Tyler's rational or linear kind of thinking, we basically move from developing a curriculum objectives to the content to implementation and then evaluation, that kind of linear thinking. So it's quite strict and sequential, but it also makes it quite rigid. It's a very much top-down approach. Yeah. So let's move quickly to TABAS. So TABAS is a little bit more flexible. It's a bottom-up approach. So it's the one which really begins with the teacher, the educator, who starts from doing a needs assessment and then moves upwards. So I think these are all not new to you again. So I'll close this part and move to the next one, which is evaluation. No, sorry, it's assessment that we're going to, not evaluation, assessment. I hope my screen is visible.
Yes. It is visible.
Okay. So, not to waste time, we shall focus on the actual assessments. Yeah. So in the computer studies, we have two kinds. We have three kinds. Sorry. The first is the diagnostic, where we are trying to determine prior knowledge, what gap is missing. The second is formative, which is ongoing. The third is summative, which is the final. So in formative, we can carry out assessments to see if, especially the practical skills, have been attained. So you have live coding or debugging sessions. Now, ICT itself, computer studies, have certain tools which can help you do that. Yeah. So I would suggest you look at some of them. For example, Java itself has some tools which can help you examine, rather do live assessment of someone's ability to code and so on and so forth. Then you have others like clicker quizzes or active learning. So here you can easily set up a quiz using either things like Google Forms, or Moodle itself has that feature. It has that feature. So this one can help you see a student's ability of understanding just certain concepts. Then we have another person's problem. This one I uploaded a video on Moodle. So this one kind of creates a puzzle. So a student may be given a bits of code, and that student can go through the process of trying to align those codes correctly. And the code itself, the application itself can help to show you where you've gone wrong. So those are just some of the things that can help in formative review. So you have the fourth is peer review. So this is where you get students to view one another, especially if you have things like portfolios, or they have come up with some bit of code, or they have set up some kind of network, whatever it is. There's that peer review. So as the studies are going on. Then you also have concept mapping. So this one also helps in trying to see if a student has picked up basic concepts. So this is where someone can visualize, or they can present a project on some of these concepts. So take an example, in programming, one may look at things like inheritance and polymorphism. Then you have summative, the second summative. So here you can have practical exams where you ask students, you time them and ask them to write a piece of code for a certain specific problem. The other is research posters or portfolios, which can be used to present on generic topics or complex topics or current topics within the world of computer studies. So here are examples like AI and ethics, computer security risks, and so on and so forth. You have project-based learning, so this can be done. You can put a project before a student. Let's say building a website for a particular company, and the students go through processes of developing and collecting data, developing the prototype, presenting it, implementation, and so on and so forth. Portfolios are another. So this one can be used to collect over time. So a student throughout the semester or the term is developing something, but they develop a portfolio which showcases everything that they've done. Oral defenses. So these are also very good because oral defenses help to build confidence, and they also help to ascertain if a student has actually done something. So here the student may be given a project where they set it up and then present it, defending what they've done. So there are certain principles that we follow with computer studies that guide computer studies assessment. The first one is constructive alignment. So here we are looking that to see that the learning objectives have actually been met. The learning objectives that we talked about in the conceptual part in the development of the curriculum. The second is evidence-centered design. Yeah. So here we are trying to determine if a particular skill has been achieved. So we want to have tangible evidence. Can a student do this? Can they program? Can they design a network? So on and so forth. Varied assessment methods. We use multiple assessment methods, so we don't just focus on one thing, but several. Use of rubrics, clearly defining the criteria for projects. Now, what is also unique to computer studies is that we have digital tools for assessment. So remember some of the things we talked about, like live coding. So you have certain IDEs or development environments which can help you monitor the coding progress. Packet tracers and simulation tools. Then we also have plagiarism detection software to ensure that the originality of code. Assessment in the computer studies world can be matched right into the real world. So here, for example, a student may be given cases which are existing. Develop something, an application for a school which you see and the needs are there. So that using live cases. Then requesting them to develop user manuals. Then at the end, they also propose actual systems for an existing business or context. Evaluation of the process as well as the final product is done in the real world. So this is the thing about computer studies, everything is within the actual, within the live environment. Why use automated assessment for computer studies? It gives immediate feedback, yeah. And then it also gives you, it also has what it is evaluating, functional correctness, coding styles, and so on and so forth. Some of the tools you can use, tools and techniques, there's unit testing. So some of the Java tools, for example, can focus on a particular function and test if it works or not, comparing output with reference solutions. And then here you're also able to mitigate risks. Rubrics. Yeah, remember we had talked about rubrics. They are also a key point in assessment. So rubrics, an example here, let's say for programming, you can focus on functionality, the quality of code, algorithm, testing and debugging. Then the rubric also would indicate levels, where you have fair, good, excellent. AI and future trends in computer studies assessment. Now, AI can also be used effectively, can also be used. AI is something a bit controversial. It can be good, it can also be very bad. But for us, for specifically in computer studies, it can help in checking code efficiency. Yeah. Then you have generative AI. That one, you can use it to teach students to use AI tools responsibly. For example, using it to evaluate the ability to analyze AI-generated code. Learning analytics, it can help the teacher see, examine data on submission times and code changes to intervene struggling students. So in conclusion, for computer studies and assessments, we must, one, understand we're using multiple assessment methods. Continuous feedback, especially informative assessment, is important, as well as summative. Aligning assessment must be aligned to the learning objectives. Then update assessment techniques based on the students' results. Okay. Before I move further, do you have a question or any comments so far? Any question or comments so far?
I think we can go on. It's fine.
Okay. Now, I would suggest that you go to Moodle. I'll give you the enrollment key for this particular module. I put up a video on Parsons problem. It's one of the assessment tools that I talked about. So I put that one up. You can find it on Moodle. So here, let's go quickly to curriculum evaluation. So here, we are trying to find out if what we're doing is right, basically, if it is effective, and it is what we set out to do in the first place. And if we need to make changes, we go ahead and do so. So key questions: learning objectives, are they being met by the students? Is the content up to date? Are the resources required to help us in teaching and learning process adequate? So again, why in computer studies? Why? Because again, technology is constantly evolving. So we want to keep up with the times, ensuring that we're in line with the industry needs, and then also assessing what we currently have, the resources we have, if they are good enough. So why evaluate? Again, going back to the industry in which we are in, it is quite fast-paced, it is constantly changing, and things become obsolete very quickly. Practicality check. Again, checking the students' ability to match the workforce needs and looking at the resources we have. So why do curriculum evaluation? We want to determine if we want to look at our strengths and weaknesses. Where can we change? So this is the formative part. This is as we're ongoing. Where is the strength? Where is the weakness? It's also giving accountability to the stakeholders, the parents, the board, the students, about what they're expecting or what has been promised. It helps in decision making on whether to keep up, revise, or discard a module. being relevant, keeping up with the changes. So there are two types of evaluation. We have formative and summative, just like in assessment, but this is for evaluation purposes. So during, as we implement, we carry out evaluation to see if what we're doing is right. And summative is at the end, where we measure the total effectiveness of the curriculum developed. So in computer studies, what would we evaluate? One, the learning objectives. Are they technically accurate? Content, is it up to date? Instructional strategies, the methods we are using, coding, the practical labs, and so on and so forth. The learning environment, do we have what we need? Computers, internet, what quality? Then learning outcomes, what students have actually picked out from the set objectives. So we have two models. We have Tyler's objective model to help us in evaluation. So this one focuses on what are the needs of the industry, other staff, do we have sufficient staff, labs, and so on and so forth. Process, how well is the course being delivered? You're looking at the methods and so on and so forth. Did students gain coding skills, the end product? Yeah, those four are the four things this model looks at. Then we have stakes continence model. So this one focuses on the stakeholder perspective, the teacher. So stakeholders would be the teacher, the students, the IT experts. We evaluate the qualitative side of things. In research method, do you remember what qualitative is?
Yes, madam.
Yes,
Yeah,
madam.
so remember the qualitative side, we're getting the total picture, understanding from the teacher side, the students, and so on and so forth. Then we have Scriven's goal-free model. So this one, the evaluator ignores the stated goals and looks for the actual effect, intended or unintended. So the quantitative methods would use here is a computer-assisted assessment, looking at, you set up, let's say, a quiz, analysis of exams, practical test results, then surveys and questionnaires. So qualitative would use peer observers, focus group discussions, looking at output of students like student portfolios, and so on and so forth. So the tools we would use, what would guide us in designing these tools? Sorry, I got disconnected. My network is not very stable. Can you hear me now?
Yes, we are hearing, but we haven't seen.
Yes, sorry, there are some breaks. My network is not so stable. So we're looking at the criteria for effective evaluation. So we're looking at validity. So here we are saying that we're looking at the things we're looking at the things that we are doing if they actually measure up. Reliability. If I was not the one marking you, would the result be the same?
Excuse me, madam.
Yes, please. Can you hear me?
Yes, but we have been still on the method. Is it one method only?
No, this is evaluation methods for evaluation.
Yes.
We looked at quantitative methods
Okay.
and then qualitative. So then we come to designing tools. How would we design them? And then we looked at the criteria for effective evaluation. So you have validity, reliability, relevance, and sustainability. So the tools we would use would, one, look at knowledge, understanding of computer architecture, the skill, the attitude. Who should be involved in evaluating the computer studies? One, the students, because they're the ones who will tell you you'd know if objectives are being made and if a change is actually happening in the knowledge of the students. Teacher, input on teachability and lab resources. The industry itself will tell you what kind of students you have. The administrators, those who are responsible for providing what is necessary. So what are the challenges in evaluating computer studies? Of course, one is the industry itself, which is constantly changing and growing. Then the high cost of updating laboratory infrastructure, other inputs. Computer studies are basically expensive. The lack of qualified instructors, especially in the new fields that we have. Balancing theoretical knowledge with practical skills. And computer studies, sometimes we value practical skills more than the theoretical knowledge. So you find students who come to class, they're more interested in the practical but not the theoretical. Then there are those who may be focused on theoretical but not the practical. But there must be a balance. So things to understand as we conclude is evaluation, like assessment, is ongoing. With computer studies, we need to consider both the practical and the theoretical. Use formative evaluation to improve and summative to judge. Key takeaways: evaluate to improve students' learning outcomes. That's it for evaluation. Do we have a question or comment? If no, then let's go to the last thing, resources. Resources that can be used by you and the students in development of the curriculum. So most of these stages we have been through already, but it is simply to point out some of the resources you can use as you develop curriculum. So most of what we point out for teachers are what would be the free and open source. So these are actual sites where you can go and see computer study curriculums that have been developed for computer studies. So this content is available for you. Then we have standards and frameworks, which can also be used. They are also freely available to help you develop computer studies curriculums. So one of the key points with computer studies is modernizing the curriculum. Yeah, we have, like we say, constantly been saying, computer studies is constantly evolving. So these are some of the ways you can modernize. Look at AI, incorporating AI literacy and ethics. Cyber security, yeah, because everyone is now digital. Data science. We are now talking about big data. As I'm using my phone, it's collecting data on me. As I'm online, data is being collected. So we need to understand what data, this data is, how it's going to be used, how we can use it, and how it can be used by others. Methodology, moving from syntax memorization to actually solving problems. The primary purpose of computer studies is to solve problems. That's the primary purpose. Curriculum mapping and design. So ensuring that topics are sequenced logically and aligned with standards. Identifying where algorithms are introduced. Aligning the first one is structure, which is aligning course objectives with planning, with program outcomes. So this is just basically a repeat. Assessment and evaluation, look at quizzes, code reviews. For summative, you look at final project portfolios. Then tools, look at rubrics and progress trackers. Inclusivity and diversity. Adopting universal design for learning principles. Culturally responsive practices, making content relevant to diverse backgrounds. gender parity, encouraging both female and engaging female students and underrepresented groups. So in summary, leverage existing frameworks, map curriculum across grades, update content for AI and security, discuss what is the big, here you can think about this yourselves, you can discuss amongst yourselves what is the biggest challenge in content in your current curriculum. So this you can discuss amongst yourselves. Do you have any question or comment?
We continue, Doctor.
Okay. So this one was the final section that we looked at in curriculum development for computer studies. I've tried to summarize. Like I said, I don't think it's anything new. I'm going to reactivate the first assignment and then put up also the second assignment in Moodle. I'm going to share with Boaz the link for the module as well as the enrollment key, unless we have any question. So for you, I don't think you need to present to me like the other group did. Simply submit the two assignments. They are both group assignments, so you can quickly do them together. And then I'm trying to liaise with the lecturer for COSI to find out what kind of exam he has set up, so that I can align with him. Is that okay?
It's okay, madam.
Okay.
Pardon,
Is there any question or comment? If none, then let me close off here and send you the necessary information. Yeah.
Okay.
Oh.
Please, madam.